Hello, we are the Wave Generator team. Team members are Jacob Dodd, Josh Fernquist, me, Mark Fry, Alethea Nielsen, and Zach Rice. Our sponsor was Brother Burgess, and our mentor was Brother Martin. Brother Burgess is a civil engineer who's done lots of work in California, dealing with things with studying water and river flow and things like that. He tasked us with making a device that would fit here inside this brandly new purchased river flume that would model ocean waves and how they interact with coastal defenses. He didn't have a lot of needs. He really just wanted it to fit in the flume, not be super expensive, be very durable, and easy to use. So our first design iteration was to build this big sheath thing that the paddle slides back and forth in that is driven by a rack and pinion. So we 3D printed our second design iteration, which is just everything in the previous slide, but the sheath was trimmed down in size a little bit. But as you can see, it wasn't very powerful. It had all the torque in the whole world, but it was too slow. So our idea was to make the pinion twice as big, which would give it twice the velocity. So we attempted that, and it still didn't work. It was a lot faster, but still not quite fast enough. So then our final design had the big pinion with a much faster motor. This motor has about it has about the same amount of torque, but 3.5 times as fast. Here is a video of it working. I'm not sure if you can hear Josh talking in the recording, but Josh is talking about how the flume is used for coastal defenses, things like that, and he's going to demo it for us right now. So all you need to do to get it to work is input the degrees of twist on the keypad, and that will make it make waves. There we go, waves. And that is the new motor in the wave generator. So the things we had to design a lot were the paddle. The paddle is the main pushing device. We designed it to be this size so that it would fit in the flume, but it wouldn't be so long that it would kind of cause a vacuum against the water it was pushing on the bottom. Also, the sheath was kind of the main backbone of the design in that everything had to connect to it. And it also had to fit in the flume. That was the main design thing with this project, is it had very limited size constraints. There's the sheath and the paddle put together with some bearings, just to do a little test to make sure they fit. And here is a CAD model of our final assembly. Everything fit together nicely. This little motor riser right here was kind of the last piece we designed because it had to be the junction point between everything else. And that was an interesting piece to design because it's had to fit a lot of strange size constraints. We originally wanted to use a motor like this, which is the motor for a windshield wiper, but turns out that we didn't want to use a stepper motor like that because the coding would be really different. This was the first motor we bought, which was too slow, and then we moved over to this one, which was about 3.3 times as fast. And this is how the entire thing is controlled. There's a program in the Arduino that was written by Josh and Jacob that controls the servo, and the user just inputs the degree they want it to twist over here on the pad, then press star, and away it goes. Zach designed the beachfront, and we had it 3D printed, so the waves would come up here and crash over it, and then based on whatever's on the top of it, that would simulate a certain kind of coastal defense, such as like here, there's a seawall, which is a very popular kind of coastal defense to kind of reflect waves, and here is a 3D modeled version of that. So we met all of our customer needs. We still have yet to determine if it has a 4-year use of life. Maybe I'll make another video in 4 years explaining it. We'll see. But there were some different things we could change about it. We could have had the motor mount and the sheath be one giant piece. Also, we could have had the paddle and the rack be one piece just for robustness. Um, we could have also had a different secure and wiring system. We could have had some custom ribbon cables made, but we just ran out of time. And that's our presentation. Uh, go down to the fluids lab and look at the thing. Hopefully it's still there because we designed it well. Thank you.